In this demonstration, we'll be asking you to load a specific file that we have already provided in the Canvas link. And let's just see how are we going to use different tools in order to make this happen. So the tool that we're going to use is Neo4j Desktop. It is something which looks like this. So basically, we'll be using it for loading this data and creating this graph database upon it. So let's just go through the steps that we have to follow in order to do this. First, we need to create a new project. Then we need to create a database under this specific project and basically set all the credentials that you must, that is the name of the database, the password, etc. Another thing that we need to do with this is that we need to configure certain properties in it. First, we need to install APOC package, it's like a plugin which we'll be using for the queries that we'll be going on with. And another thing that is important is commenting out the specific line, that is dbms directories.import. So let's just begin with it. This is the console, which gives me the Neo4j desktop interface. In order to create a new project, you can click on New, and a new project will be created. So if you want to name it something, you can just click on the Edit button, and maybe I'm gonna name it Demo, Project Demo. The next thing that we need to do is basically specify a database with which we're going to work with. So we'll go to Add and say local DBMS. So we basically want to add a new local DBMS, and you can set the password as per your convenience in here and hit Create. So this may take a while, maybe a minute to get created. So we have to be a little patient with it. Yeah. So now it has been created. So first thing that you want to do is to start it, to check if it gets started properly or not. Basically, you will get a symbol saying that the status is in start mode, and you'll get an option of stop in here. So basically, whenever you want to create any kind of queries, we'll be able to execute them only if the database is in starting phase. So this is very important to start the database before you go on with analyzing your data or writing any kind of queries on it. This will also take a while maybe, but like it is in active state now, so we can use it. So let's just make the changes on the configurations that we wanted to. So in order to do that, first go to these three dots, press Settings. Here you'll be able to see a lot of directories that are being imported. So basically you can just go and comment this specific line that we wanted to and say apply. This is giving us an option to restart it. I'm going to say restart it later because we need to make one more change to it. And that is that we need to add that specific plugin that we talked about. So go to plugins. In here, click on the database first, go to plugins, go to APOC and say install and restart. And this option will basically install it as well as restart this database so that you can use it further. So we can see that the database has now been started and now we can use it. So in order to use it, we basically use a Neo4j browser to write all the queries that you have in order to analyze the data. So to go to that console, you can press open button in here, which tells us that open with Neo4j browser. So you can click it and the corresponding console will appear. Another way is actually accessing it through a URL, which has been provided in the Canvas. So that is also a way to do it. Also, I've gone through this problem that uh, sometimes this browser does not get open. That was because my specific version of Neo4j was not up to date. So make sure that if you want to access your browser through that open button, your version of Neo4j should be up to date so that it'll not cause any problem to you in future. So we can now get started. So let's go through this presentation. We have started the project. We have opened our Neo4j browser now, and now we want to analyze the data. So the two data CSV files that we're going to use for this workshop is general information and GPS information. So for the link for both of these files, that is the data will be given to you, and you can download it in your personal system so that you will get a specific path where you have saved that specific file. That path is very important for us because basically it's our key to access the data set. So while you are making this specific path, make sure that there is no spaces in the path because else it'll give us an error in future. So in order to load these files from your personal uh, computers, you will have to give the path to your file in here, and this is the syntax of having a peek of what your data is. So let's just see how it works. For me, the path is this, so I'm going to use this command to access the data that I have. So I go to Neo4j browser, enter it, and run it. So let's just see what this command was for so that we could get an intuition of what the query is actually doing. So first you can see that it is loading my CSV with headers. So just to have a peek at the CSV, this is the CSV file, and it has headers provided along with it. So we can say that you can read this specific file with the headers. And with every record that it is reading, it basically is returning me one line, and the limit is one. So basically, it is giving me only one record at random from this Excel file. This is the record which it's returning me. It basically giving me address, effectiveness of care national comparison, and more information about what the data is there in this specific file. So now that we know in this specific state, we are not creating any graph or any relationship. You can see that in here, the node label, relationship type, property key is all empty because we're just having a peek at what the data is. We're not doing anything to it currently. So in order to structure the data in graph database format, we need to execute a lot of queries, which we'll be doing now. So let's just see what all do we need to do from this point forth. First is creating indexes. So basically, we can create an index over a property on any node that has been given a label. It is a very good idea to define indexes whenever you feel that a specific node is going to have a lot of data. So in defining indexes helps us to retrieve data in a very fast manner. So it is a very good step to define your indexes so that the retrieval process of the query or the performance of your query will be very fast. So that's what we're doing in here. So let's just discuss its syntax for a while. We are saying create index, and we're giving a name to this specific index like index underscore name. And we are specifying the node and the specific label on which we want to create this index and the specific property that we want to create this index on. So it is very important that the name of these indexes should be different, because if you give same name to two different indexes, it is going to throw an error. So let's just copy this and execute it once. So we can see that it is getting executed. And the minute it gets executed, I get node labels in here. So these labels which I defined the indexes on have been created in my database now. Address, city, county, and zip code. In case there is a chance that you want to see what all indexes have you actually executed as of now, you can use this command to see what all indexes have been defined in this database. So you say call db.indexes, and you get the list of all the indexes that you have executed or defined as of now. So this is the first step towards structuring your database. And then another thing that we could do in here is adding constraints to it. So this is a unique constraint that we are creating on the label hospital, telling that every hospital ID should be unique. Basically, it makes sense, right? If there are two different hospitals, they should not have the same ID. So by defining this constraint, we're actually making sure that the data that we have has is integral. That is, the data integrity is intact. So we can create these constraints on the database. And in order to see what all constraints have you executed as of now, there is another statement that you can run, which is called db.constraint. You can run it. And so we can see that we have two constraints in here. So that is the way to have a basic structure, and basically these steps make sure that you have data integrity as well as good query performance in the future. So in order to create a good structure of this graph, we'll have to run this specific query. This is a cipher query, and let's just go line by line about what it's actually doing. So it is telling us that first I want to load my file from this specific location, which we have been doing till now. But we have a constraint, a filter in here, which tells that the state of every row should be NY, that is New York. So in this specific set, we're only dealing with the rows which have New York State. So only the rows which have New York State, or maybe nodes in this case, will be accounted for. Then we see this specific command called merge. So merge either matches the existing nodes and binds them, or it creates new data and binds that. So in this case, we're saying that node for a state will be created, which in our case is New York. And note that there might be multiple rows in this specific data set that will be having NY as its state, but only one node will be created. Another thing that we can see in here is that we're building a hierarchy. So we can see that merge creates a node called county, and it says that it is in a relationship with state. It actually makes sense, right? County is always there in a state. A city is always there in a county. A zip is in city, and an address is in zip. So basically, we'll be creating these node labels so that we know what is the relationship between every node that we'll be accounting for in this database. Another thing we can see is that the node for hospital has been created by in this statement, wherein provider id every different provider id that you get in your data set will be created as a node, and that will be having one is in relationship with address. So let's just execute it and see what will happen. So we see that after the execution, I have additional labels, nodes, and properties created in here. So, and also you can see that getting reflected in this pane. Earlier, we only had the node label, but now we have additional labels that we defined in that query. That is hospital, the relationship type of is in, property keys like ID and name. So this is basically, this is the part where we're creating a graph for it. Another command that we would like to look at while creating this graph data base is set command. So you can see that in the next slide, I have this query, which we'll be executing next. When we see through it, it is similar to what we had earlier. That is, we are getting a file, getting the file, we're saying that the state should be New York, and we're matching every provider ID that we're getting and seeing and basically accounting for a node which has a provider ID. Now it is using this property, this command called set. Basically, set clause is used to update labels on node and properties on nodes, or as well as for relationships. So we actually, for a specific node that we get for a hospital, we want to add more properties for it, like phone, emergency services, name, mortality, safety, timeliness, etc. So these commands are adding additional properties to your nodes. Other than that, we're also creating more nodes like type, and we are defining its relationship with hospital. Like a hospital might be of different types, right? So a hospital is in a has type relationship with type node in here. Also, a hospital must be having an owner. So the ownership node will be related to hospital as has ownership. A hospital can also have a rating, and that newly created rating node will be related with hospital with has rating relationship. So let's just execute and see what happens. So we see that new labels, 17 labels and 17 node has been created, and there has been a set property operation and relationship creation. This is something that we can actually see in this pane. Rating, ownership, node labels have been added, new relationships have been added, new property keys have been added through this specific command. Another thing that we can do in here is that was the reason that we added another file for analyzing, which was basically the GPS information. So, how does GPS information look like? It basically gives us the information of the provider ID and its longitude and latitude. So, what if I want to add this information to my existing hospital node? This is something that we can do with this command. We are loading this second file. Sorry. We are loading the second file, that is the GPS information in on this console, and we are saying that every hospital's latitude should be set to the latitude if the ID from this file matches any ID in my node label hospital. So using this, you can also add additional properties using different files, which basically gives you the power of using multiple files and creating a single database out of it. So this is something which you can use to integrate different files in one platform. So let's just go through this and see how can we analyze what we have created as of now. So in order to analyze and visualize what we have created till now, there is a command called call db.schema.visualize. This is something which we can execute in this console and see what we have actually created as of now. So here you can see that we have different label nodes and how they are actually being related to one another. Like here, this is the node for hospital. You can see underneath in here that this is the node for hospital, and it has relationship with ratings, has type relationship with hospital type, and all the relationships that we have basically uh, instantiated right now, we will be able to see in this specific graph. So let's say that we want to analyze the nodes that we have. Match n, return n, limit 14 is something that you can use to check whether the graph was populated successfully uh, or not. So you can see the nodes that have been created as of now. You run this and you basically see the limit 14 nodes. That is one node of state, which is at the top of our hierarchy. Then count for county, we get 13 rows. So basically it is showing us these nodes in a specific hierarchy. So what if I say that I want to see 60 nodes? So what it will do is that it will return you the first node for state, 57 nodes for county, and 2 nodes for city. So basically, it is going in the specific hierarchy that we define. That is, first comes the address, then over it we have zip, over it we have city, then county, then state. So this is something which is quite interesting to analyze. So what if you decide that you want to analyze only a specific label? So for that also we have a command in here. Basically, you can define the label that you want to analyze the nodes for. So if you want to analyze only the nodes for city, you can run this command and you'll be able to see only the nodes for city label. So, like in SQL, we had a lot of operations wherein we calculated average and count of numbers, etc. In here also we can do the same thing, but the syntax is a bit different. So let's say that for a specific city, I want to count the number of hospitals which it has. For that case, this is the command that I can basically this is the query that I can build to get that information out. So what we see in here is that we are getting this relationship wherein wherein I want city is in a specific hospital relationship. From this, I want the city name and the count of hospital that every city has. Also, we can do order by in here, wherein basically you can order your data according to a specific order, like we can do in SQL. An interesting thing in here is this. It basically defines the level of hierarchy that you want to work with. So for us, first label was address, second was zip, and third was city. So basically, this is defining the city label that we want the information from. So when we run this, we get the information about every city and the number of hospital which it has in an ordered format. So let's say that now you want information about zip. That is, you want to know that for which zip, for a specific zip, how many hospitals are there. So for that, you can change the label and change it to 2 because zip is something which comes in second level of hierarchy that we have defined. So you can run this and see that the number of hospital in every city is there, in every zip is this. Similarly, you can do the same thing for street as well. Like if you want to see the number of hospital in a specific address, you just change the syntax, the label to 1 and get the number of hospitals which are there in every address. So this is a way that you can analyze this. Um, Further, you can also get information from multiple nodes. So let's say that I want to know that for a specific owner, what is the average rating for that specific owner. So basically, for this specific relationship, we'll be needing the entity of hospital to be involved because hospital has a has rating relationship with ratings and a has ownership relationship with owners. You need the owner information from O, which you get as o.name as ownership, and you need the rating information from r, that is r.name, and you calculate average rating of it. And then like you do in SQL, you will be able to execute this specific query. So when you sorry. So when you do it, basically you get the information of every ownership and the average rating for it. So this is how we can go on analyzing the data that you're working with in from a CSV format. Another way of doing this, that this is the same query that we did for the number of hospitals in a specific city, but you have a where clause in here. So basically you can also filter the data that you have, like you can do in SQL. So yeah, so basically these are certain ways in which you can analyze the data and see how you can work with data that are situated in different CSV files with Neo4j. I would actually recommend you to practice this a bit, because there are a lot of ways in which you can create these specific queries and you can get the same answers out of it. So practice it, and yeah, this will be something which will be very helpful for your projects as well. So that's it for today, and thank you for giving me your time, and yeah, enjoy your weekend.